Let's start today section 5.4. Section 5.4 is called Logarithmic Functions. Let me write that out for you. Logarithmic Functions. Now, first of all, before we can work with logarithmic functions, we have to know what they are. And I'm going to back up for just a second and take us back to when we were working with just linear functions. Y equals 3x plus 7. Let's say we take that graph and we wanted to graph it. 3x, let's make it 3x plus 2. I don't want to have numbers quite that big. 3x plus 2. Our initial value is 2. We have a constant slope of rise of 3 and run of 1. So falling 3, left 1. And here's the equation, y equals 3x plus 2. What if I asked you to find the inverse function? Do you remember inverse functions from the first part of chapter 5 when we did chapter 5 at the beginning of the school year? Think about how we found the inverse functions. We looked at the line y equals x. Here it is, right here, y equals x. We looked at that line, y equals x. And inverse functions were a mirror image of our function across y equals x. Now that could be kind of hard to graph, except I know this point right here is 0, 2. I know this point right here is 1, 5. And I know this point right here is negative 1, negative 1. Do you remember that by swapping the x and y, let's start, swap x and y. We're going to just switch places with them. If I plot 1, 5, and I switch those to 5, 1. So we're going to go 1, 2, 3, 4, 5, 1. And then I'm going to plot 2, 0. And then negative 1 is still negative 1, negative 1. I now have the line right here that is the inverse of that function. Now, how did we go about finding that? Well, we took the equation and we swapped the x and the y. We swapped the x and the y. And then we solved for our new y. We subtracted 2 from both sides. And then we divided by 3. So 1/3 x minus 2/3 equals y. And if you look, that crosses at about negative 2/3. And if I start here and go up 2 and right 3, up 1 and right 3, up 1 and right 3, I have a slope of 1/3. So that's inverse functions. The problem is, let's take an exponential function. Let's say y equals 3 to the x power. And let's swap our x and y. We've got x equals 3 to the y power. Now those are inverses. The problem is, how do I solve that? How do I isolate the y? The y is an exponent. How do you get that by itself? Well, mathematicians realized that following the steps of just switching the x and y and then using the algorithm to solve for y is not going to work for exponential functions. So instead, what they did was they created a new format. And it's a way to isolate, look what they isolated. They isolated the exponent. They swapped x and y, so now y is the exponent. Look right here, y is the exponent in this problem. And then when they wrote it as a log function where the exponent is what's isolated. Log functions are for isolating the exponent of y. Now the format for how we're going to do that, I will tell you, the textbook shows you an exact format. But I have students all the time getting confused as to where does the exponent go, where does the number go, where does the y go, where does everything go? So I have a slightly different format that I'm going to show you I do. You're welcome to use that, or you're welcome to use another format. That's up to you. But instead of writing y equals 3 to the x, I wrote b to the exponent equals some number. So let's say that I had 3 to the 5th equals 32. Okay? So I have b is the base, stands for b, base. E is the exponent. My exponent is 5. And the number that it created was 32. So b to the exponent is a number. Now, it also happens to spell the word Ben, which is my son's name, which is probably why I like this system. When I want to rewrite this, though, I say my son is not feeling himself. And so instead of being Ben, B-E-N, he becomes Benet. Notice the base has moved to a subscript. The base is now the subscript of my new notation. The number has moved into the notation itself, and the exponent is what's isolated. So if I wanted to take this, the base, exponent, and number, and rewrite it in log format, I would write log base 3. The 3 is a subscript, which means it's below. Like if this was a lined piece of paper, it's kind of a little below the line. Of the number, which was 32, is equal to the exponent. And we could solve using a calculator or whatever methods we want. Actually, 3 to the 5th is not 32. Let's make it 2 to the 5th. Sorry about that. Let's make a problem that really works. Base of 2, that we could type in log base of 2 of 32 and just get the answer is 5. Now, you're not going to get calculators to use, so unfortunately we have to find another way to do that. But when we look at this problem, remember we already learned in section 5.3 that we could write 2 to the 5th equals 2 to what power? And since we know the bases are the same and I know they're equal to each other, then x has to be 5. The exponent had to be 5. Sometimes, though, it's not about solving them. Sometimes it's just about rewriting them. So let's take a look at our examples here and what they're asking me to do. I'm going to start with example 2. We'll come back to this one in a minute. It says change the following exponential statements to log statements. So in order to do that, I have to recognize there is my base, there is my exponent right there, and there is my number right there. So my base was 1.2, my number is m, and my exponent is 3. So when I rewrite it, I'm going to write log base 1.2 of m. Do you hear how I'm saying that? Log base 1.2 of m is equal to 3. Now this, to be honest with you, I would just do 1.2 to the 3rd power to find the letter m if it had asked me to solve, but it didn't. It just asked me to change it from one format to the other. So I did log base 1.2 of m, the number, is equal to 3. Let's take a look at this one. What's the base? The base is e, the number is 9, and the exponent is the letter b. So I'm going to write log base e of the number 9 is equal to b. And now we have converted from exponential to logarithmic. Let's do one more. Think about what your base is, what your number is, and what your exponent is. Notice how I'm reading it even in the format of log base b of the number equals e. So that is log base a of 24 is equal to 4. And we can also go backwards. We can take it and say, all right, this is log base a of 4 equals 5. There's my base right there. There's the exponent, and there's the number. So I've got the base of a to the 5th power is equal to 4. On this problem, it's a base of e to the negative 3rd power is equal to b. And you might want to use our property that said this is equal to 1 over e to the 3rd if the problem says do not leave any negative exponents. Either one of these answers would be fine. We're going to say or, because both of these answers are the same thing. That's called leaving your answer in terms of e, and it is absolutely a correct answer. It is a real answer, just like in terms of pi, we left this answer in terms of e. And what about this last one? It's base of 3 to the exponent of c is equal to 5. 3 to the c power is equal to 5. Okay? So let's talk about, that's just how to convert it, but why would we even want to? Well, let's go back to this problem right here. They've told me I've got y equals log base 3 of x, and x is 81. So let me rewrite that. Log base 3 of 81 is equal to x. Well, let me rewrite it. Let's change this to 3 to the x power. There's the base, there's the exponent, is equal to 81. Now we look on our list, and we find that 81 is 3 to the second, third, fourth power. 3 to the x equals 3 to the fourth. My bases are the same. So we just solved this problem right here. X is equal to 4. And it was a lot easier to work with when it was in an exponent form and we could use our table of exponents. Let's take a look at this problem. Y is equal to log base 5 of x, and they've told me x is 1/5. So let me rewrite it. Y equals log base 5 of 1/5. Okay, so I'm going to rewrite this. I'm going to say 5 to the y power is equal to 1/5 because we got there's the base, there's the number, there's the exponent, and there's the number. Base, number, exponent. Base, exponent, number. Ben. Well, they don't have the same base. So let me rewrite this. 5 to the y equals 5 to the -1. Y must be -1. And we've solved that problem a lot easier than trying to figure out from looking at this. All right, let's keep solving. We're just going to get a little more complex. Let's take this problem and rewrite it either from log to exponent or vice versa, which means we might start with exponent and go to log. And we're going to solve for the variable x in this problem right here. Well, the base is 2, the exponent is 3, so that's 2 to the third power equals 2x plus 1. Well, 2 to the third power is 8. Oh, that's easy to solve. I can subtract 1, 7 equals 2x, divide both sides by 2, 7/2 is equal to x. We solved this problem much easier by converting it into exponent form. Let's take a look at this one. We've got x is the base, exponent of 3 equals 343. So I'm looking in the column, I'm going to look at my table, where do I find the number 343? Well, the number 343 is in the third column from 7. So 7 to the first, 7 to the second, 7 to the third. So x to the third equals 7 to the third. If the exponents match, then x must be 7. Much easier to solve. Now you're saying, well, obviously exponents are easier to solve than logarithms. Okay, but what about this problem? This problem solving for x, first of all, we have to get e to some power by itself. So we're going to divide by 2 right away. E to the 3x equals 6 divided by 2, which is 3. To get x by itself in this case, because the whole goal is to get x by itself, I am going to have to rewrite this as a log problem. And I'm going to write it as log base e of 3 is equal to 3x. Now, I have log base e of 3 equals 3x. X is almost alone. I'm going to divide both sides by 3. And you're going to be very tempted to divide those 3's out. You can't. Because this 3 is part of a function. It would be like taking square root of 3 over 3. You can't mark those out either. That doesn't work. So we can't mark those 3's out. But what we can say is x is equal to log base e of 3 all over 3. And we're done. That is the answer. So that's solving without a calculator either logarithm or exponential equations.